Welcome back, Patriots. I hope you all are ready to go on this first lesson of 2021. We got an exciting semester coming up. We're going to have that STAR test we've got to do later on this year. So we got to make sure we're going strong, getting you guys all ready for that. So the first thing we'll talk about is what in the world is this thing that is labeled here as a system of equations. Okay. Now, what we did all last semester was we took a variable or an equation, something like 2x is equal to 8, and then we learned all of our different strategies to solve it. In this particular case, we're just dividing everything by 2 and x equals 4. We may have made that more complicated, and we would like do something like 2x plus 6 is equal to 8, and there's more steps in order to do that. But you'll notice that anytime we actually solved, and when I say solve, I mean got down to the point of x equals a number, it was always a single variable with only one equation. You'll also notice that we may have done stuff like this, where we had 2x plus 3y is equal to 9. And we did do some solving steps on these. We would subtract 2x from both sides. That would give me 3y is equal to negative 2x plus 9. We would then divide by 3. And we would get y is equal to negative 2/3 x plus 3. But that gave us the equation for a line, and then we then focused on what was my slope and my y-intercept, but we didn't actually get down to the point of saying that x equals a number and y equals a number. And the reason we did that, or we couldn't do that, is because when you have two variables inside of the same equation, there is absolutely no way for you to get down to the idea of x equals one number and y equals one number, because you've got this entire set of points. And remember how we talked about on a line, I should have done that with a different color, like green. Every single point that is on that line is a set of points that makes this equation true. And so you can't just say it's x equals one number and y equals another number. Now, a system of equations is something that looks like this, where notice I have two variables. I've got x and I've got y. But you'll also notice that along with two variables, I've also got two equations. Now, when I have two variables and two equations, I can solve it. And by solve, I mean I can find a very unique set of points or a set of coordinates, an x, y coordinate pair that will make both of these equations true at the same time. Now, what that looks like is that, let me go ahead and jump down here. The first equation is going to give me a line like this red line. The second equation is going to give me a line like this blue line. Now, if a point is a solution to both, then that means it is going to be the one unique point that is shared by both points, or the intersection point, by both lines, or the intersection point of those two lines. So that's what we're looking for whenever we're trying to solve a system of equations, is what is that one specific point that makes both equations true at the same time. And we'll talk about all the different variations on that as we go. Now, what you're going to notice this unit is we're going to start off today learning how to solve systems using graphs and tables. Then we're going to take a couple of days to talk about different ways of solving them using a method called elimination, a method called substitution, a method called matrices, and then we're going to spend the very last day talking about how to solve them when they're all mixed together. And all the way through the unit, we'll talk to you about the different situations where it'd be best to use each method. But this entire unit is going to be all about solving equations when you have two equations and two variables. And just a little preview for what's going to come on later, you actually can do this with 3 variables and 3 equations, 4 variables and 4 equations. We would never go beyond that. Honestly, in Algebra 2, we'll cover 3 variable systems, but we're not going to do that, I don't believe, at all this year. We might do 1 or 2 just as an example, but we don't ever really go beyond 4 anywhere in high school. But you, in theory, could, solve a system of equations that has 40 variables, and you can do that as long as you have 40 equations. So let's go ahead and go through our notes here. Solution to a system. A solution is a point or an ordered pair that is common to both equations. Okay, it is the point on the graph where the two functions intersect. And just like I said earlier, it is going to be the place that makes them both true at the same time. And the way that we check that, for example, like on number 1 here, if I ask you as a point 5 for a solution, we're going to check that by substituting x and y into both equations, and both of them must be true. So here's what we're going to do. Take that top equation, 2, we'll replace the x with parentheses and replace the y with parentheses. And I'm going to do some substitution because the x is 5, so I'm going to plug that in for 5. Y is 4, so I'm going to plug in the 4 for y. Now we're just going to simplify down. 2 times 5 is 10, minus 2 times 4 is 8, equals -2. Oh, you know what? I made a mistake. I wrote that down wrong. That should be a 3, not a 2. I apologize. And then we're going to replace that. 3 times 4 is 12. 10 minus 12 is -2 equals -2, and that is true. Okay, now we got to check it into the other equation, though. And I'm going to do that one over here. Negative parentheses minus 2 parentheses equals -13. We're still going to plug in 5 for x, and we're going to plug in 4 for y. Now we're just going to simplify down. Negative times 5 is -5. -2 times 4 is -8 equals -13. And now we're going to simplify. -5 minus 8, sure enough, is -13. Which gives me -13 equals -13, and that is true. So when it is true on both sides, then the answer is yes. It is a solution. Okay, now let's try our second one. Again, we're going to replace x and y both with a set of parentheses. And now let's go ahead and plug in. X is 2 in this case, and y is -1. So that gives me 2. And now 2 times -1 is -2. Why do I keep doing that? I did it again. I wrote a 2 when I meant to write a 3. Oh boy, that's going to give me 3 times -1 is -3 equals -1, which is -1 equals -1. Once again, that is true. Okay, let me erase this because it's in the way. Now let's go ahead and plug in on the second equation. 3, I did it again, I wrote a 2. 3 parentheses plus 2 parentheses equals 8. Now we're going to plug in a 2 for x and then a -1 for y. And now we simplify. 3 times 2 is 6. 2 times -1 is -2 equals 8. And now this one gives me 4 equals 8, which is not true. That is a false statement. So, is it a solution? No. Since it is not true for both. Okay, now to solve a system using a table. What we're doing as we go through here is we're looking for a place where the x and y coordinate are the same. Now, the x is going to be the same list all the way down, but we're looking for a place where the y values match. So I go across here, I see 1, -3, 0, -2, -1, and -1. That matches on both, which that tells me that my solution is 3, -1. So you're just looking for the point that they have in common. Okay, now on this one, I'm going to go down and look for it. Negative 7, 3, no, 8, 12, 9, 9, to negative 10, 30, and negative 11 and 39. So at first glance, we don't have a solution on this table, but the good thing is we have a calculator that we can use to be able to help us out with this. So what I'm going to do is I'm going to jump over to the calculator, and I'm going to go to y equals. Now in y equals, for y1, I'm going to go ahead and type in the first equation. Now, remember this right here, this negative 1/3, we type in as negative 1 divided by 3, and then times x minus 7. The second one we're going to type in as 3x plus 3. Now, the way that we go to the table is, see up here above the graph button, we have the table written in blue. On the physical calculators in class, it might look a little bit different. But these also, by the way, should be installed on your Chromebooks that are issued by GISD. It should be in your app drawer, so you should be able to get this calculator in some way. But anyway, we're going to go to second, and then press the graph button will take us to the table. Now, when we do that, the first one we typed in is going to be y1. The second one we typed in is y2. So you can see we've got the negative 7, 3. If we go down to 3, we got negative 8, 12. And if I were just to press the down arrow and scroll through this table, it looks like these numbers are getting farther and farther apart. So what if I went the other direction? What if I went up and looked at the table and, oh, sure enough, I see a 3, negative 6. Sorry, if I went to negative 3, I would get negative 6 and negative 6, and that would be the solution that I'm looking for. So my solution here is negative 3 and then negative 6. And I know that was a little bit weird, but don't worry, this will be a lot easier to do, or that particular problem will be a lot easier to do with some of the other methods we'll be talking about later on this unit. So let's jump on to number 5. Now we're going to be doing this one using the calculator. That's why these are already labeled as y1 and y2. So let's go in the calculator, go ahead and jump over to y equals again. Let's use the clear button to clear out both of those. Go to y1, we're going to type in x plus 1. And we're going to go into x2 and do negative x plus 3. We're going to go to the table again. Again, that's up here, second table. And let's scroll up and down and see what we can come up with. Again, negative 6 and 10, negative 5 and 9, negative 4 and 8. Those don't look very close at all. Oh, right here I'm seeing 1 and then 2 and 2. So I'm going to use these values as I'm filling in my table. My x values, let's just go with 0, 1, 2, 3, and 4, and then also 5. For y1, my values are starting at 0. Go down once, it's all right there. So I've got 1, 2, 3, 4, 5, 6. And then y2 was 3, 2, 1, 0, negative 1, negative 2. And the answer I'm looking for is a place where they are equal. So my solution is at 1, 2. Okay, let's run the exact same thing for number 6. We're going to go to y equals. Clear out both of them. And then 3x minus 5. And for y2, x minus 3. Now, just in case you don't remember, x is going to be this button right here beside alpha, the one that has x, t, theta, and n. Now we're going to go to second table once again and look to see if we can find one where they intersect. Let's see, 13 and 3, that's a difference of, wait, did I type it in right? 3x minus 5 and x minus 3. Yes, I did. That's a difference of 10. Here goes to 8. Here we got, oh, yeah, negative 2 and negative 2 right there. So 0, 1, 2, 3, 4, 5. y1 is negative 5, negative 2, 1, 4, 7, and 10. And y2 is negative 3, negative 2, negative 1, 0, 1, and 2. And we're looking for that place where they have an equal y value. So our solution is at 1, -2. Okay, like I said, those are going to start getting a little bit easier with our different methods later on. Okay, so that was how to solve when we have tables. Now, when we're looking at graphs, the graph actually gives us the ability to see there are actually 3 different possibilities here. And this is very similar to back when we were solving equations. And let's jump back to that. Let's say that we ended up at the end of an equation, we had something like x equals 2. Well, we would say that that had 1 solution. Now, if we had an equation that looked something like this, let's say it was 2x plus 3 is equal to 2x plus 3. When we did our solving steps, we would subtract 2x on both sides, and then that would leave me with 3 equals 3. All the variables went away. And in that particular situation, because this was true, we said that it had infinitely many solutions. Now, that's very different from an equation that had something like this. 2x plus 3 is equal to 2x minus 7. Because when we did this problem, we'd subtract 2x on both sides, and we'd left with 3 equals -7. And the variables all went away. However, it's not true. So what we'd say is that this one has no solutions. So we had 1 solution, infinitely many solutions, and no solutions. Now, over here, we have a very similar idea, but we're doing the graphs instead of individual points. And this time we can actually see what it looks like. Now, we already talked about how where they cross right here, that is exactly 1 solution. However, it's also possible that I have parallel lines. Now, in parallel lines, these two are never going to meet because they run side by side, never get closer together, and never touch. Therefore, they don't share any points, and there are no solutions. Now, the other possibility here is that the lines actually lay directly on top of each other. They are the same line, the same y-intercept and same slope. And this one was supposed to show that it was both blue and red at the same time, but they really are the exact same line. The blue line goes right there, right with it. And in that case, they're touching everywhere. Therefore, every single point is a solution, and it's infinitely many solutions. So those are our 3 possibilities and what we're going to be looking for. Now, the way we're going to go about that is by graphing them, and make sure, as you're going through these, make sure that both of them say y equals. We may have to pull out some of our skills from last semester to make it say y equals. The second thing we're going to do, just graph the slope and y-intercept, graph the lines, and then find our point of intersection if they have one. So let's go ahead and go through this, and I'm going to do my top line in blue and my bottom line in red. So first off, when I look at my blue line, I can see that my slope is 3 over 1, and my y-intercept is -5. So I go to my y-intercept of -5 first. Then I rise 1, 2, 3, run 1, rise 1, 2, 3, run 1, 1, 2, 3, run 1, and I'm going to pull out my ruler so that I can draw that line. And then in red, I can see that my my slope, again, there's no number listed there, so my slope is 1. And then my y-intercept is -3. So I jump over to -3, rise 1, run 1, rise 1, run 1, rise 1, run 1. Draw that line. And I can see now that my point of intersection is this point right here, which happens at 1, -2. Okay, let's jump over to example 4. Again, top line is going to be blue. So my slope is 1 over 1. My y-intercept is 1. So I jump up to 1, rise 1, run 1, and draw the line. And now for my bottom line, I'm going to do in red. Slope here is -1, so it's -1/1, and the y-intercept is 3. So y-intercept of 3, rise 1, or go down 1, run 1, down 1, run 1, down 1, run 1. Make sure you're always thinking about what would slope dudes say, and that this one is going to be falling because it's a nice negative. And the place where they intersect is right here at 1, 2. Okay? Now, example 5, this is the first one we have where it doesn't exactly have y equals at the beginning. So I'm going to have to do that one. I'm going to jump over here, -2x plus y is equal to 4. Now, I'm going to fix that by adding 2x on both sides, which leaves me with y equals 2x plus 4. Then from there I can see that my slope is 2/1 and my y-intercept is 4. So jump over to 4. Rise 2, run 1, which I can't really graph on there, so I have to go the opposite direction. Down to left 1, down to left 1. And then let's draw that line. And now in red, this one has a slope of, now don't be fooled because it's written backwards, slope is always the coefficient of x, so it's 2/1. And then my slope is the constant, which is -5. And I am going to rise 2, run 1, rise 2, run 1, rise 2, run 1. And now it doesn't look like these are getting any closer together. And sure enough, I've got a slope of 2 and a slope of 2, which means that they are going to rise and run at the same rate. These two are parallel, which means there is no solution. That happens when the slopes are equal and the y-intercepts are different. Okay. Number 6. Let's go ahead and take care of our first one in blue. Here the slope is 1/2 and the y-intercept is -5. So go down to -5, rise 1, run 2, rise 1, run 2. Draw the line. And now for the next one, I'm going to divide by 2, and we divide everything by 2, and that's going to give me y equals, now -10 divided by 2 is -5, and then plus 1/2 x. So now we write our slope, which is, again, the coefficient of x, so that's 1/2. My y-intercept is the constant, which is -5. So I go down to -5, and then I rise 1, run 2, rise 1, run 2, and sure enough, it looks like this is the exact same line. The two lines are directly on top of each other. So this one, we're going to say that it has infinitely many solutions. Okay, so those are my two special cases. Number 5, where they're parallel and there's no solutions. 6 is where they're the same line and infinitely many. And you'll notice that on both of them, over here in number 5, they both have the slope of 2/1. Over here, they have the slope of 1/2. The difference in them is that here our y-intercepts are different, but on the right, the y-intercepts are the same. And I realized I wrote something wrong. That's a -5, but I did it correctly. So, okay, number 5. Again, we need to get y by itself on both of these. So I'm going to take the first equation, x plus 2y equals 8. We are going to subtract x on both sides, which gives me 2y equals negative x plus 8. Now we're going to divide everything by 2, and that gives me y equals negative 1/2 x, remember because that's a negative 1 there. Negative 1 divided by 2 is negative 1/2. 8 plus 2 is, or 8 divided by 2 is 4, which means my slope is negative 1/2 and my y-intercept is 4. So I go to my y-intercept of 4. My slope is negative 1/2, so it's down 1, right 2, down 1, right 2, and then we graph the line. Now, for the second equation, I'm going to jump down here below because I have some room. Y minus 2x equals negative 1. We are going to add 2x to both sides. Gives me y is equal to 2x minus 1. Now, what that means is that my slope here is 2 over 1, and my y-intercept is negative 1. So I'm going to jump down to negative 1 as my y-intercept. Now I'm going to rise 2, run 1, rise 2, run 1, down to left 1. And now we're going to draw the line. And the place where they intersect is right here. It looks like the coordinates at that point is 2, 3. So that's all for today. Remember that system of equations, first off, is when we have multiple equations and multiple variables. The place that you find the solution is where the 2 points are where the same point makes both equations true. On a table, you find that by looking for the place where both y values are the same for the same x value. And on a graph, you're looking for the place where they intersect. Of course, checking for your special cases of parallel and for the same line, which are no solutions and infinitely many solutions respectively. Otherwise, if they just have a single intersection, it's the place where they cross. So good luck on your assignment. Feel free to reach out if you have any questions.